There's a motor spinning inside a wheel right now that engineers said couldn't exist. It weighs less than a car tire, produces more torque than a supercar.
Tesla built a motor so advanced it made today's electric vehicles feel outdated. Its latest innovation is more than a simple upgrade. It could redefine EV performance, efficiency, and durability. With faster acceleration, stronger energy use, and greater resilience, this breakthrough may shape the future of transportation far beyond cars. But the real question is not just how powerful it is. It's whether this motor gives Tesla a lead so massive that competitors struggle to catch up. The motor that's breaking limits. Tesla's new electric motor has sent shockwaves through the automotive world, but its true power lies beneath the surface. At first glance, it might look like just another upgrade. Stronger, lighter, maybe a bit faster. Yet this is much more than incremental improvement. The heart of Tesla's breakthrough is a rotor wrapped in carbon fiber, pushing electric motor design into uncharted territory. Rotors are the spinning parts inside electric motors that convert electrical energy into the torque you feel pressing you back in the seat. For decades, these rotors have been made mostly of copper and steel alloys. While reliable, these traditional materials hit physical limits when pushed to high rotational speeds due to centrifugal forces that deform and overheat the rotor. This limits how fast and efficiently a motor can operate. What Tesla has done is radically different. By encasing the rotor in a tightly wrapped carbon fiber sleeve, they have managed to tame these forces, allowing the rotor to safely spin beyond 20,000 revolutions per minute, far faster than virtually any other electric motor on market today. At that speed, power output soars and acceleration becomes hypercar territory, yet in an electric sedan. This change isn't just about raw speed. It fundamentally alters how the motor behaves under strain and heat. Traditional metal rotors suffer from expanding and warping when they get hot, leading to imbalances and mechanical wear. The carbon sleeve effectively clamps the rotor, maintaining its shape and balance no matter the temperature. This keeps the motor stable, efficient, and reliable over longer periods. Still, most people outside the engineering world are unaware of the magnitude of this innovation. To them, it might seem like just a technical detail or a clever marketing point, but this tiny design change unlocks a cascade of benefits: faster acceleration, longer range, and greater durability. It creates a positive feedback loop where improvement in one area uplifts others. Tesla's motor is already on the market, installed in the Model S Plaid, Music, which rockets from 0 to 60 mph in under 2 seconds, a time once reserved for multi-million-dollar hypercars. While these numbers grab headlines, the quiet revolution here is about how efficiently this power is delivered and maintained. Efficiency means less heat, less battery drain, and more miles per charge. Metrics that all EV buyers care deeply about. Yet, how does Tesla achieve such a feat without giving away the secret to every competitor? After all, the design is patented and openly available. The answer is more than just blueprints. It is in the precision manufacturing and material science behind the carbon fiber wrapping. Tesla has mastered a process so exacting it cannot be easily copied without the same technological infrastructure. While the motor looks like a simple assembly, making it involves robotic systems controlled by artificial intelligence that manage tension, temperature, and precision down to the micrometer. In other words, Tesla's edge isn't just genius engineering, but a factory-level mastery few can replicate at scale. The full story of how this motor shatters previous limitations is more remarkable than it first appears, and it's what we'll uncover next. Understanding this breakthrough requires stepping back and seeing Tesla's journey not as a single event, but as a chain of innovation that reshaped the electric vehicle industry over 2 decades. That context reveals why this motor is not just a product, but a milestone in Tesla's relentless quest to redefine transportation. As Tesla redefines the possible with this motor, it helps to look back at the roots of the company and the disruptive path that led here. The history behind the revolution. Tesla's rise from an electric car startup to some kind of industry leader is kind of a tale built on stubborn vision and non-stop innovation. Clears throat. Around 2003, when Martin Eberhard and Mark Tarpenning founded Tesla Motors in a small California garage, electric cars were often laughed off. They were treated like slow, awkward gadgets that couldn't really match gasoline vehicles on power, range, or style. Big automakers didn't see much of a future there, so the whole mainstream electric cars idea felt like a bit too far of a reach. Enter Elon Musk in 2004, and it wasn't just about putting in money. He came with this kind of radical mindset that kind of reworked Tesla's DNA. For Musk, electric cars were never some slow, polite compromise or charity. His point stayed pretty sharp. Build the most beautiful, fastest, and most thrilling vehicles on the road, and show that electric propulsion can actually outperform traditional engines. That attitude basically powered Tesla's first real breakthroughs and shifted the whole story people told about EVs. The 2008 Tesla Roadster was the first big okay, wow moment. It was built on a Lotus chassis, and it surprised a lot of skeptics by going beyond the performance of several gasoline sports cars. It wasn't only a car, it was more like a statement that electric motors could create genuine visceral power. Tesla didn't just arrive at parity, they jumped ahead. That early hit basically set up everything that followed. Then, in 2012, Tesla raised the intensity again with the Model S, a luxury sedan packed with innovations like a huge touchscreen, over-the-air updates, and performance that made established automakers feel a little shaken. After that, the Model X showed up, and eventually more accessible options like the Model 3 and Model Y widened Tesla's audience from enthusiasts to the mass market. Every next step nudged the industry to hurry up and catch up, which turned into this loud, almost frantic race music to electrify fleets. Yet, when competitors started scrambling, quite a few people figured Tesla had peaked, like the company's edge was kind of thin, and that whole golden age was about to taper off any moment. But they kind of missed how Tesla can keep going. Still, almost under the radar, with that slow, steady kind of revolutionary progress that happens under the surface. While everyone else was chasing today's version of Tesla, the company was already assembling what comes next, a sort of tomorrow leap. Tesla's newest motor, the one with the carbon-sleeved rotor, is basically that next leap. It's the latest chapter in this ongoing habit of disruption, where small incremental gains end up becoming a real rethinking of what electric motors can do. And this isn't just some lone marvel either. It's more like the result of years of research, lots of testing, and honestly, a willingness to question the regular engineering truths that everyone keeps repeating. That longer background is why Tesla's motor feels substantial, not like some sudden stunt. It's not only a one-off surprise, but also part of a recurring pattern where boundaries get nudged again and again. And Tesla's ability to blend design, software, and mass production together has really separated it from the rest. Plus, it helped make this new motor feasible. In a way, those roots explain why this isn't merely another engine, but more a milestone that could nudge the entire EV industry into a reset. That foundation is crucial to understanding the next question. Why is carbon fiber the material choice that makes this motor so revolutionary? A look at physics and engineering explains why traditional materials had to give way, why carbon fiber music changes everything. Carbon fiber's rise in high-performance engineering isn't new. Formula One racers, aircraft, and spacecraft have used it for decades. What makes it special is its unmatched stiffness-to-weight ratio. It is incredibly light, but rigid. And crucially, it can handle tensile forces at extreme speeds better than metal alloys. For an electric motor rotor, this matters more than most people realize. Inside an electric motor, the rotor spins rapidly, converting electrical energy into mechanical motion. At high speeds, centrifugal forces pull outward on its components, straining the metal and risking deformation. Metals like steel and copper expand, warp, or lose shape when pushed too far, or when heat builds up. That damages motor efficiency and longevity, limiting just how fast a motor can safely spin. Wrapping the rotor in a carbon fiber sleeve changes everything. The carbon fiber applies a constant compressive force known as preload that holds the rotor tightly together, preventing it from deforming under extreme rotation. This structural support lets Tesla's rotors spin beyond 20,000 revolutions per minute, speeds that would shatter traditional metal rotors. The result is more power, more speed, and far greater durability. Because the carbon sleeve is lighter than steel, it reduces the motor's rotational mass. Less energy is needed to spin the rotor, which improves efficiency and range. This efficiency means the vehicle can go farther on the same battery charge, and the cooling system experiences less strain. That extends battery life and lowers operational costs, vital factors for any electric vehicle owner. Thermal stability is another overlooked advantage. Metals expand unevenly with heat, causing subtle imbalances that degrade performance over time. Carbon fiber's expansion properties differ significantly, allowing it to maintain consistent pressure and balance regardless of temperature changes. This ensures stable operation even during intense use. Despite sounding simple, creating a perfectly wrapped carbon fiber sleeve is incredibly complex. The difference in thermal expansion between metal and carbon fiber requires precision application to avoid cracking, peeling, or imbalance. Tesla had to innovate manufacturing techniques and build robotic systems guided by artificial intelligence to achieve micrometer-level accuracy in wrapping the fibers. This exacting process demonstrates Tesla's commitment not just to engineering theory, but to real-world production at scale, a combination that gives the motor both brilliance and practicality. No competing automaker has yet replicated this precise manufacturing mastery, putting Tesla ahead on both design and execution. Carbon fiber is not a gimmick. It is the structural heart of Tesla's motor revolution. It transforms theoretical limits into everyday performance in a way no metal rotor ever could. This material choice unlocks the exceptional speed, power, and reliability that now defines the pinnacle of electric motor technology. With this understanding of carbon fiber's crucial role, the full depth of Tesla's breakthrough gleams into view. Not just a new motor, but a new path for electric vehicles and beyond. Every great innovation depends on mastering not only design, but the challenge of making it real in the factory. That story continues next. The manufacturing challenge. Moving Tesla's carbon-wrapped rotor from an early idea into real mass output was not an easy road. Not even close. The main problem sits in the careful physics linking carbon fiber with metal. They both react to heat, but in different ways. So when temperature moves, these materials expand and contract at their own pace. That gap creates a pretty real threat of cracking or even parts subtly pulling apart. If the carbon fiber layer is placed too loose, you can get wobble, instability, that kind of trouble. But if it's squeezed on too tightly, then you risk harming the rotor body itself. Getting that in-between sweet spot, where everything fits just right, meant manufacturing precision at a scale you rarely see in everyday auto work. So, Tesla built a whole new production approach, not just a tweak, with advanced robotics plus artificial intelligence. The setup oversees the whole wrapping routine and controls the tiny variables: tension, travel speed, ambient temperature, and yes, even the precise angle where the fiber ends up laid down. Keeping everything consistent down to the micrometer level, basically 1/1000 of a millimeter. is what matters most because the rotor has to run safely and repeatably at more than music, 20,000 revolutions per minute. The carbon fiber layers have to be perfectly even with no deviation whatsoever that could make a mechanical imbalance during operation. Tesla's AI-guided robotic systems use laser sensors to watch the whole process in real time, and they catch even the tiniest irregularities before they turn into critical failures, or whatever you want to call them. Each rotor gets a very strict inspection before it ever sees the assembly line. So only flawless units end up in the motor build. That kind of quality assurance is honestly unheard of in normal electric motor manufacturing. What looks like a sleek, simple component is actually backed by years of small iteration, testing, and refinement. Thousands of prototype rotors were wrapped, tested, thrown away, and improved again just to sharpen the whole process. Tesla's engineers had to learn not only material science, but also production engineering, and they even developed new equipment specifically for this kind of work. This whole design-manufacture dance is a core strength of Tesla, but it's often ignored in the mainstream coverage you usually see. And the robotic system's AI is trained through hundreds of tests to figure out the exact tension needed for each distinct rotor. Even small shifts from factory temperature or humidity can change what optimal really means. So, there has to be constant adjustment in real time, turning the manufacturing workflow into a sort of living adaptive system, not a rigid assembly line that just runs the same steps forever. It's a pretty clear example of how Tesla's innovation ties software, hardware, and manufacturing technology together in one unified thing, even if most people don't realize it. While the patents for the carbon sleeve technology do spell out the rotor design, the real secret sauce lives in this manufacturing mastery. No other automaker has managed to copy these exacting robotics or the AI systems Tesla cooked up for production. This kind of technological ecosystem, design plus execution, is what actually makes Tesla's motor stand out. Having the blueprints, but not the ability to build in a consistent way at scale, feels like having a recipe with no kitchen or no chef. This complexity also helps explain why the motor hit the market later than people expected, until Tesla could guarantee quality at mass production levels. Scaling a delicate process up to tens of thousands of units per month takes more than just innovative machines. It needs specialized training for operators and a supply chain that's properly tuned for carbon fiber materials. Tesla's music, gigafactories are not just about output numbers. They also represent all those connected capabilities working together. At the core, Tesla's approach shows a pretty deep realization. Tech by itself doesn't do the job. Execution at scale with non-stop quality control and automation that keeps getting sharper matters just as much when you're trying to turn breakthrough ideas into products people can actually buy. That blend of innovation and industrialization is the hidden edge in this motor revolution. And honestly, this manufacturing sophistication then feeds into Tesla's broader strategy, too, including a decision that can sound almost backwards compared to what a more traditional business playbook would suggest. Opening patents is unusual in a fiercely competitive industry like automotive engineering. Yet, Tesla chose a different path with this motor technology, the open patent gamble. In a move few companies would dare, Tesla openly published the patents for its carbon-sleeved rotor technology. This means that any automaker worldwide can access the detailed designs and theoretically build the same motor. On the surface, this openness might seem to risk Tesla's competitive lead. Why share your best secret with potential rivals? Tesla's reasoning goes beyond generosity or idealism. It's a strategic gambit to showcase the size of the technological gap rather than conceal it. By laying bare their design, Tesla is daring competitors to catch up, not just in concept, but in execution. The patents reveal the rotor design, but say nothing about the robotic systems, AI algorithms, quality assurance processes, and manufacturing scale needed to produce it consistently. Knowing the recipe is not the same as being able to cook the dish perfectly. The barriers to entry remain daunting. This transparency doubles as an unspoken challenge. Tesla is confident that rivals cannot reverse engineer and mass-produce this motor at Tesla's level anytime soon. It's a statement of dominance that few companies have made before in such a visible way. By doing this, Tesla signals that their advantage lies as much in disciplined integration and industrial depth as in intellectual property. In addition, opening the patents invites collaboration and accelerates industry progress toward better electric motors overall. Tesla recognizes that the global shift to electric transportation benefits from broader innovation rather than isolated silos. This openness could foster partnerships, standardization, and faster development of electric technology across the board. However, the timing is also key. Tesla has already established production lines, mastery of complex robotic processes, music and supply chains for the carbon materials. Competitors, meanwhile, face years of investment and learning curves before they approach similar levels of proficiency. The patents merely set a roadmap rather than provide a shortcut. Moreover, Tesla's motor is embedded within an ecosystem, including battery design, software control, and vehicle integration that is difficult to replicate. Music, even if a competitor copies the motor perfectly, integrating it into a car for efficient, reliable operation is another monumental task. Tesla's advantage comes from years of refining all these components simultaneously. This strategy echoes Tesla's ethos of move fast and show your work. It broadcasts confidence and invites others to rise to the challenge, knowing that the gap between invention and mastery is vast. It's a rare blend of openness and tactical superiority, rarely seen in the tech or automotive worlds. Tesla's move puts immense pressure on competitors to not just innovate, but to scale innovation practically and robustly. This patent openness raises an intriguing question. How has the broader industry reacted to Tesla's carbon fiber rotor breakthrough and this bold gamble? The answer reveals key hints about the competitive landscape and the forces shaping EV technology today. Even as Tesla lays out the roadmap, rivals are forced to decide whether they can build the tools, factories, and expertise to match or surpass what Tesla has created. The industry's response. Tesla's unveiling of the carbon-sleeved rotor motor made quite a stir across the auto world. Yet somehow those little ripples haven't fully turned into bigger waves of copying right away. A few rivals answered with silence, like they were stuck on how to even process a leap that big. Others waved it off, calling it a niche edge and saying it probably won't nudge the mainstream much. At the same time, though, several automakers sped up their internal work, quietly trying to close that gap, but they run into those steep and annoying hurdles. Lucid Motors kind of stands out as the sharpest engineering opponent. Their Air Grand Touring performance claims more than 500 miles of range, plus a drivetrain setup that pushes back against Tesla's efficiency story. Still, a lot of Lucid's problem is just scale, not idea. They move only limited numbers, largely aiming at that ultra-luxury corner, far away from the mass market where Tesla really holds the ground. And since Lucid doesn't have the same production volume, plus the same financial muscle, their overall reach stays kind of boxed in. Rivian charts like a different road, focusing on electric trucks and SUVs made for outdoor adventures. It's got Amazon money behind it, and a pretty loyal crowd of buyers. So, Rivian has basically shown that demand is real for electric pickups and utility vehicles. Technically, though, Rivian still leans on more standard motor designs, and so a lot of their innovations feel more incremental. In that way, they haven't really kept pace with Tesla's latest sort of quantum jump. And yeah, that widening performance gap in motor tech really points to Tesla's earlier head start in this space. Big mainstream players like Ford, have also been making visible progress. Stuff like the F-150 Lightning shows that electric pickups can sell, and they don't just sit on lots. Still, Ford's whole setup is split between internal combustion and electric cars, so it can't fully pour resources into next-generation motor technology. Plus, there's that dependence on outside suppliers for batteries and motors, which means less control over the pieces that actually matter. That setup then makes it harder for Ford to line up directly against Tesla's more cutting-edge work, at least on the technical side. General Motors has put tens of billions into electrification with the Ultium platform, trying to reshuffle its lineup and move faster. But in practice, there have been problems, and the rollout has taken longer than expected. Sure, Chevy and Cadillac electric models have gotten attention, but none of them quite landed that transformative wow factor that people associate with Tesla's carbon-sleeved motor concept. GM's approach feels pragmatic, more steady than flashy, but it still doesn't deliver the sudden disruptive spark Tesla managed to ignite. Meanwhile, Chinese powerhouse BYD has kind of overtaken Tesla in global EV sales. And it also has a vertically integrated supply chain that's hard to match or even counter. BYD makes its own batteries, chips, and the smaller components too, at lower costs, so there's this clear manufacturing edge. Still, BYD is dealing with an uphill battle in brand recognition and software ecosystem strength. Music, especially over in the United States. People aged 45 and up often stick with names they already know, and that keeps Tesla's kind of home market advantage intact. So this fragmented situation means that right now, no single competitor is really threatening Tesla across every major front at once. Lucid brings engineering brilliance, but it doesn't have the same scale. BYD has scale, but the Western brand strength is still a limited thing. Ford and GM, they have legacy brand power, yet they lag when it comes to the base EV technology. Tesla, meanwhile, has that near-complete package: innovation, scale, brand, and manufacturing know-how, all in one. Tesla's motor innovation, plus its integrated way of doing things, seems to raise the bar so high that rivals are facing a climb not only in technology, but in execution and in actual market presence. In this situation, the question shifts from can someone copy Tesla to how fast they can build similar capabilities that actually hold up in the real world. As Tesla redefines electric motors, their vision hints at transformations across multiple sectors, signaling a broader impact waiting just beyond the horizon. The next evolution is about more than cars. It's about redefining how electric motors power the future. The motor's future potential. Elon Musk's new motor steps into territory that crosses beyond the roads and highways we know. The carbon-sleeved rotor's combination of exceptional power-to-weight ratio, high rotational speed, and thermal stability opens doors to applications once limited by the weaknesses of conventional motors. This technology could be the breakthrough that electric aviation desperately needs. Electric aircraft propulsion has long been held back by weight and efficiency constraints. Motors must be incredibly light, yet deliver sustained power safely in extreme conditions. Current solutions often come with trade-offs: too heavy to make electric vertical takeoff and landing aircraft practical, or insufficiently efficient over a broad speed range. Tesla's motor ticks all the right boxes, offering a lightweight, powerful, and reliable option that can maintain performance at high revolutions per minute. Several startups racing to develop electric air taxis or small passenger drones face propulsion challenges that mirror early EV struggles. Tesla's motor may solve a central puzzle for electric aviation propulsion, accelerating viability for this nascent industry. While Tesla has not officially committed to licensing the motor for aircraft use, subtle signals suggest this application lies within its strategic vision. Moving from the air to the grid, high-efficiency electric motors are also critical in energy infrastructure. Wind turbines, industrial pumps, and large-scale storage systems all require robust motors capable of enduring harsh conditions and continuous operation. Tesla's ability to mass-produce these advanced motors at lower costs could reshape multiple clean energy sectors, extending its influence well beyond vehicles. Tesla already manufactures megapack batteries for national grids and Powerwall systems for homes, positioning the company as a holistic clean energy provider. Integrating their motor technology into energy generation and storage equipment could cement Tesla as a key hardware supplier for the global energy transition. This path transforms Tesla from an automaker into an energy and mobility platform of the 21st century. As the company pushes forward, the ripples from this innovation may soon become tides, reshaping entire industries. Risks and the road ahead. Tesla's new motor looks like a major breakthrough, but the future of it depends on more than just raw performance, or whatever you want to call it. The carbon-sleeved rotor setup needs extreme precision, costly inputs, specialized manufacturing steps, and very strict quality control. Because of that, the plaid motor comes out pricier than the usual electric motors, so people keep asking if Tesla can push this same innovation into cheaper trims, like the Model 3 or Model Y. Still, the financial pressure makes the road ahead feel more tangled. Tesla's been dealing with tightening margins, layoffs, and non-stop price competition, especially from Chinese automakers such as BYD, SAIC, and NIO. They make vehicles at huge scale and with lower costs, and that kind of proves a point. Superior technology doesn't automatically turn into market dominance or anything like that. Tesla's brand is also kind of tied to Elon Musk. His bold leadership has pushed Tesla's major breakthroughs, yet the controversies and things he says in public can mess with customer and investor confidence. For a lot of buyers, trust in the business matters just as much as the tech specs, maybe even more, depending on the person. Charging infrastructure stays a rough spot, too. Tesla's supercharger network is still very capable and strong, but letting other brands use it reduces a bit of that special exclusivity. Range anxiety is still there as well, especially in places where fast charging isn't steady or really reliable. Then there's the whole self-driving story, which adds even more uncertainty. Tesla has moved forward. Still, the timing on full autonomy has slipped, and that has affected credibility. Software dependability, regulation, and public sentiment might end up shaping Tesla's future as much as the motor engineering does. In the end, Tesla's plaid motor shows what can be done, but the EV competition isn't really settled yet. Rivals like Lucid, BYD, Ford, and GM keep improving, so Tesla has to keep balancing new ideas with actual execution. Tesla's new motor is a game changer, blending speed, efficiency, and durability in a package few can match. Yet the story doesn't end with breakthrough technology. It's about how that technology navigates cost, competition, and consumer trust. As the race accelerates, the next few years will shape the future of electric vehicles for decades. If you found this deep dive insightful, please like the video and subscribe for more analyses that go beyond the headlines and unpack how innovation is reshaping our world.